Some people have had some questions on numbers 2 and 3. All right, I started filling in this problem, A, B, and C, putting the parts into it. Some people said that the discriminant, the part under the radical, comes out to be a negative, and you can't take the square root of a negative. That's true, you can't take the square root of a negative, but be careful. It's a negative 4 times 5, which makes negative 20. Negative 20 times negative 42 makes a positive 840. Now, 121 and 840 make 961. And I doubt very many of you know offhand that the square root of 961 is 31. Okay, you may not know that. You can use a calculator, so don't freak out. You can use a calculator to find out the square root of a number. That's not illegal. You're big boys and girls now, you can use calculators. But so when you do this, you've got a negative 11 plus or minus 31, all divided by 2 times a, which is 10. Okay, now the good news is I can look at this right now. 11 and 31 are always going to make a number that ends in 0, either by addition or subtraction, whatever. It's going to work out nice and neat. And this works out pretty neatly for the two answers. One of them will be a fraction, the other one won't be. But you just have to play around with these. This one right here, you have to move the negative 4 over to the other side, and it should end up making this a negative 86, or I'm sorry, 84, when you add the 4 to the other side. But again, you've got to be careful when you place this number. It is negative in here. So I am not a personal fan of the quadratic formula. The quadratic formula, to me, makes this problem substantially easier than the old method of setting it up into the quadratic equation and then factoring it into two binomials. Okay, it actually works really, really nicely if you do it that way. What do I mean? You don't always have to use the only time you have to use the quadratic formula is when it says use the quadratic formula. If I'm given a problem, 5x squared plus 11x minus 42 is equal to 0, I know automatically it is x plus and x minus. I know that. And I know 5 is going to be 5 and 1. But 42, that's where we get into a little bit of hairiness. 1 times 42, 2 times 21, 3 times 14, 4 doesn't go in, 5 doesn't go in, 6 times 7. So you've got all those choices. I'm already seeing, to make 11 in the middle, there's only one thing that I can do to make 11 in the middle. I'm going to put the 5 and the 1 there. You could flip-flop it, but you'd get it wrong. I'm going to put the 5 and 1 there, and I know that 5 times a negative 2 make negative 10x, and the 21 times 1 is a positive 21x. They together make a positive 10, or 11, I'm sorry, a positive 11x. Okay, now if you do factoring of trinomials a lot, this gets substantially easier for you. And to me, if I'm going to solve this, 5x plus 21 equals 0, and x minus 2 is equal to 0. X is easy. Oh, I'm sorry. Add the 2. X is equal to 2 for one of the answers. Now this one, you're going to subtract 21 and divide by 5. So x is equal to negative 21 fifths. That's the other answer if you do the formula in the other problem, negative 21 fifths, when you work it out using the quadratic formula. But those would be the two answers. If it says use the quadratic formula, use the quadratic formula on the test. But for me, I start to use things that I'm more comfortable with. And if you can do factoring quickly like I can, you can find these answers sometimes faster than using the crazy quadratic formula. Now, it's beneficial, knowing and finding the discriminant and things like that, but the test, you'll have a couple of them. Work on the quadratic formula. I'm going to post a video on completing the square, which is similar to this method right here, completing the square and working on that. And again, some of you are going to love the quadratic formula because you get to use a calculator and it helps you out with that. Some of you are going to prefer the factoring into binomials and setting them equal to 0. Others are going to like other methods. Don't worry, they're all good methods. There's only a few of each of them on the test. We're going to go over that today. All right.